So welcome to UAS3 training chapter 2. In this chapter we'll be talking about creating, editing tree structure and creating and editing measurement points. So let's move to our UAS3. I certainly hope you have your software open, and in the last chapter we stopped exactly here. So we have been looking into the demo data, but now it's time to do some of our own job. So let's move now to data folder that we created at the very beginning that we named your manual. So please click here and click on the tree structure. We have two tree structures inside, training and example that we made building 2A. Click on the training and click open. Okay, so this is now our tree structure that we will work on and we will try to build. Of course, it's empty right now. So what we want to do now is first we will think about our assets and what we want to monitor, what will be here inside. Is it going to be one process, and that process will be divided into workstations and assets, sub-assets and non-repairable items? Will it be two parallel processes? Will it be certain asset groups that perform similar tasks? Well, that's the decision you need to make, and this is part of our training. Not this one, but implementation training, that you will learn how to build that logic within your organization. In this training, we will actually focus on how to practically do it in UAS3, how to manage it in UAS3. So use the right click and add new asset. So that asset can now be a pump group, a fan group, it can be process number 1, process number 2, certain sub-process, whatever you want to do. Just think about hierarchy, think about logic. And that's something you need to do, and you will learn at implementation training. So I will call this a recirculation. Why? Right. So now I have a first level, a node called recirculation. But I just made a mistake and I will just repair it. Recirculation of what? So what you will do now is you will click on this, right click and click edit. So I will call it a water recirculation. It makes much more sense. And I will save it. Now don't forget that all these tools you have here as well. Cut, copy, paste, delete, set node alarm, add to work order, survey to each instrument. You can all do it from here as well. But you know, we are all quite used to working with the clicks on the mouse, so you will probably find this more comfortable way. Of course, you can also use your mouse, arrow left, arrow right, and it will open next node. If I go down, it will just go to the next node on the same level. Okay, so within that water recirculation, let's say we still have some more work to do, and we will create a pump group number 1. Pump group 1. Fine. Now we have our pump group 1, and within that pump group 1, we probably have pump number 1. Pump 1. And I will save it here. Right, you can see now that we are now building these branches of our tree, and they are set in a very logical way. So I have pump number 1, and that pump has several assets within, and one of them will be certainly a motor, and another one will be a pump itself. Of course, depending on your configuration, here you see I made a mistake, and that's a good opportunity for you to see, because motor is not under the pump. So I will delete it here, and I'll put it on the right place within the pump 1. So add new asset, and it's going to be pump. Note that I'm making a difference between a pump as a complete asset. So I'm using a capital P, and the pump itself, which is part of that pump asset, pump train, and I'm using a small p. So it's done just because it will make it so easier later to search the database and to understand what is what. So maybe I have a whole train, pump number 1, and a backup is pump number 2. But for instance, if I want just to check a cavitation on a pump volute, I will search for the pump with small p. So it will make things quite easier because we have to see the difference between a pump and a pump. And it's quite important to do it in the beginning instead of repairing your database later. It will be quite painful. So let's say that in a motor we have measurement point, which we will call non-drive end bearing. Nice. Note that I used a measurement point because the non-drive end bearing is actually a measurement point. A motor is not a measurement point. The motor still contains two different, at least minimum 2 different measurement points. But the non-drive end bearing is a measurement point itself. Very often we use a term also a repairable and non-repairable item. So you can use this logic here as well. Then the non-drive end bearing is a non-repairable item. We cannot go deeper than that. So we will be doing the measurements on non-drive end bearing, and therefore we will use a measurement point. And you can see if I click on non-drive end bearing, I cannot add asset, I cannot add measurement point anymore. Now it's time for me to add measurement settings. So this means following hierarchy nicely and going logically from the root of the tree, timber, branches, and then to the leaves. And the leaves are actually measurement settings. So at this point, I hope you understand how easily you can build a tree structure. You just need to follow the logic that you created before. So use the right click and add something there. You can delete, you can cut, copy, paste, do whatever you want. I will show you later what does it mean copy and copy structure only. Now within this non-drive end bearing, I will add some measurement settings. Now this is quite important part, so I hope you are doing this together with me on your software and practicing. So here in the creating measurement settings, first you can choose a sensor. So I have certain sensors here defined, and if you remember in a demo data structure, we defined certain sensors. We removed the sensors we don't have in our box. We didn't do it here. So you see what happens. The UAS3 is offering me absolutely all sensors that are used with 340, simply because I did not limit it before. So let's do it right now. So I will close this. I will not do that at this time. I will go to options, system settings. Here in the tab sensors, you will see that all of the sensors are now checked. So let's say I don't have this one, I don't have this one, I have this one. Let's say I don't have a paradish, just to make it a little bit more interesting. I will remove ultrasense because probably I don't have it. So those are the sensors I have, and this is what I will be using during my job. Let's remove the flex ID as well. Okay, so save and close. And if I move now to set my measurement settings, and I open first question is what sensor you want to use here. So let's see what's offered. You see, the only thing offered are actually the things I have in my box. So it makes it a little bit easier, and I really suggest you to do this because it's faster and more simple. So let's say on the motor non-drive end, I intend to use, let's say I have a guide, I have a button, so probably I can use RS2T. In some cases, you will only be able to use needle on the grease nipple, but let's say in this case that we have an opportunity, there is a bore through the cover and we can touch the bearing. RS2T. Now the next question you need to define is what will be the sample rate, because the UAS3 will differentiate RS2T sensor or each sensor, also by the sample rate. So you can use the same sensor in the same point with different sampling rate, and it will be considered as two sensors. So let's say I want to really be very precise, and I will use focus mode 256 kilosamples per second. Fine, so that's defined. Filter frequency is 36.1 to 40.7 kilohertz. Fine, we don't do it. The category name is automatically generated based on my settings. So it says RS2T, focus mode 256K. This is coming from two of my settings. So that's going to be name of this measurement setting. What I need to do is to set interval, but let's say I'm lazy. I just don't have an idea when I will do the measurement. I will do it occasionally, sometimes when I have free time. And let's make the acquisition time. So acquisition time for a normal operating 1500 RPM or something like that, 3 seconds will be more than enough. Just for fun, let's put 5 seconds. Let's put 1 minute and 5 seconds. You see, I cannot move to 2 minutes. If you see what I'm doing on the screen, I'm clicking up. Because UAS3 is automatically calculated what is the maximum acquisition time for this sampling rate. So I can switch to seconds, and I can move up to 1 minute and 15 seconds. Of course, I don't need that much time, but I just wanted to show you that it's automatically limited to possible acquisition time. You cannot make that mistake. And not making mistake is a good thing, and we are trying to stop you in every case. So let's put 5 seconds. Good, and now I will save my settings because I'm happy. But as you can see, I cannot save it because the interval is mandatory. That is included recently in UAS3, because if you want to do a proper condition monitoring, there must be some rules. And one of the rules is interval. When you need to collect that data, you can change your interval as much as you want, but interval needs to be defined. Another reason to do that is because UAS3 will offer you a reminder for the missed measurements, for the measurements you planned to do, but for some reason you forgot to do. So there must be an interval. Okay, we'll respect that, and we will say that we will do it every month. So you can choose the interval value and the unit. It can be hours, days, weeks, and months. Let's say I want to do it every month. So I defined RS2T, focus 256, every month, duration of the measurement 5 seconds. Save. Fine. As you can see now, the measurement is here. The measurement setting is here, exactly where it should be. And this small sign here is telling me that there is no measurement inside. So it's empty, it's just the settings. We don't have any measurements saved. And that's good, because sometimes you will just go through, you don't need to open every point because you know that there's no measurement inside. Now, another good question is why there's no measurement inside. It should be, you should do the job, but we will address that question a little bit later. So what I can do now is set another measurement, because I don't want to do only this. I need to do more work. So I will also measure temperature. And of course, it's very logical to use the same interval, because it doesn't make much sense to go every month to measure ultrasound and then every 45 days to measure temperature. It doesn't really make much sense. So, and then we need to set the emissivity. You can set the emissivity any way you want in UAS3. It's completely open, so you can do it, but you need to know the emissivity. So let's say in this case it's 0.93, it's typical in industry, but even if you leave 1, it won't be a correct measurement, temperature measurement, because it ain't going to be a correct temperature, but for the trending purposes, it will make sense. Of course, if you leave 1, your trending will be fine. It will show you increase, decrease, or staying the same. But if you want to have a correct temperature, please get informed about what is the emissivity of that particular surface. Put the right emissivity, and you will have the right thing there. Okay, now we also want to do some other measurements. We want to measure vibration. And I'm doing it on purpose this way, because then you will see that we made a mistake and we will repair that mistake. The reason is because that's a classical mistake you will make, so that this is a good opportunity to do it. Yes, I want to use my accelerometer. I want to use a sampling rate of 64. I want to have a lot of 64,000 samples per second, a lot. Now I need to define what will be a filter frequency. So you have 5 Hertz to 1 kilohertz, 10 Hertz to 1 kilohertz, and 10 Hertz to 10 kilohertz. Depending on what you are going to measure, and that's not the purpose of this training, to teach you how to collect the vibration measurement, just to do the settings. You will choose one of those, or you will make all the settings for all 3 of them. I will choose this one. And you see the category name is immediately assigned. It's accelerometer 100, raw measurement 10 Hertz to 1 kilohertz, 64K. Fine. If we change it, it will be a different measurement. So I can have several of them here inside. Logically, the interval will be the same every month, and I will do it 3 seconds. That's just fine. But now I have a question to myself, because this is going to be probably vertical, radially vertical measurement. But I also want to add horizontal. So that seems that I need to go a step back. I did something wrong. So if I save it here, you can see I have it here. Everything is fine. But the problem is now that if I want to make it one vertical, one horizontal, and one axial, I cannot do it in one point, because the point will not let me to have the same settings for the same sensor multiple times. So it's not fine. And now I want to remind you what we said in the beginning. Don't make 1,000 measurement points and then go and work and realize you made a mistake in the beginning. So it's better that you make all your mistakes in the beginning, fix them, and then continue. After that, you'll be doing a lot of copy paste. It's going to be quite easy work if you do the job right the first time. So what we realize here is that we have a non-drive end bearing, but we need to consider vertical, horizontal, and axial as 3 different positions. So let's do this. Non-drive end. First, let's add more vibration settings. So we did 10 Hertz to 1 kilohertz. So let's do the same thing with 10 Hertz to 10 kilohertz. Let's say we need that kind of measurement. So this is the way you will set it. You will leave 3 seconds and you will say save. So everything is here. So right now the settings we want to define for this point is here. The only trick is that we need to do it 3 times. Vertical, horizontal, and axial, considering that we are doing vibration as well. So let's repair this small mistake from the beginning, and let's edit this point and say non-drive end bearing vertical. Save. Of course now we need horizontal and we need axial, but now we already did some jobs, so why not doing some copy paste? So I will use copy structure only in this case. Copy structure only means that it will copy the hierarchy. It will not copy the data. When you click copy, it will copy the hierarchy with all included data. In this particular case, when it's completely empty, it doesn't really make any difference. But in future, when you want to copy certain hierarchy, for instance, you have the pump and now you have the same new pump, you want to copy the hierarchy, click copy structure only to avoid copying data, just to help yourself and copy the hierarchy. So let's copy structure only, move 1 level up to the motor and paste it 2 times. Okay, now we have non-drive end bearing vertical in brackets 1 and 2. So we will edit it now and we will say that this one is not vertical, it's actually horizontal. And this one is not vertical too, but it's actually axial. Good. Now let's see what we have now here inside. We can open them all and see that we have ultrasound in all 3 of them. We have temperature in all 3 of them, but we don't need that actually. So if we check before where is the perfect position to measure ultrasound, so where we have the highest possible highest possible signal. Let's say we have it in the horizontal position, and we will remove this measurement setting. So we will remove it from vertical, and we will leave the temperature, because at that point, or on a grease fitting, it's a good point to measure temperature. I will leave ultrasound in horizontal, but I will remove the temperature because I don't need to measure it on 3 points. And on axial, I will of course remove ultrasound, and I will remove temperature. Fine. Now we have the configuration exactly as it should be. So we have pump group 1, pump 1 on the motor, non-drive end side. You can call it any way you want, outboard, number 1, or whatever bearing. I usually use non-drive end. And we have a vertical measurement where we will take a measurement on the grease nipple for the temperature, and we will take the measurement of vibration. Horizontally, we will take vibration and ultrasound, because ultrasound we need only in one direction. And then we will go down to axial, where we don't need ultrasound, we took it already. We don't need temperature, we took it already. So let's just do the vibration. So here is the whole configuration for non-drive end, for the non-drive end bearing. But it still doesn't work really nice if you want to be really precise, and something that they call me very often a nerd. So now in the motor we have non-drive end bearing vertical, non-drive end bearing horizontal, non-drive end bearing axial. The logic tells you that the next thing we will build will be drive end vertical, horizontal, and axial. So just to give you an option, some people like to have it divided. So they say motor, non-drive end, and within non-drive end they will put non-drive end vertical, non-drive end horizontal, non-drive end axial. If you want to do it that way, do it that way, that's fine. It will not bring much of an added value, it will just give you one more node, and it might complicate things a little, but if you want to do it, it's absolutely okay, no problem about it. Let's now understand that probably on a drive end we will be taking the same measurements as on non-drive end. So we will copy this one, say copy structure, go one step up, and we will paste it 1, or you can use Ctrl V 2 times, 3 times. And what I will do here is first edit. I will remove this, and I will remove non-drive end, and it will be drive end. Save. So I have my drive end bearing. I will do the same thing with other 2 measurements. So this is going to be horizontal. I hope you are stopping me right now and saying you made a mistake. Yes, we did make a mistake, and those mistakes are here for the tutorial, so you will not make them. What we did is that we copied non-drive end bearing vertical into the 3 additional points, while we should be copying non-drive end bearing vertical, horizontal, and axial separately. The reason for that is because they contain different measurements. What we did right now is that in drive end, what we wanted to be drive end, we copied everything from non-drive end vertical. And that's a mistake, and that's a nice one that you will not do in the future. So you will delete this, you will delete this, and you will leave drive end bearing vertical, fine, because we copied drive end bearing vertical here. Now copy non-drive end bearing horizontal, copy structure only, go up to the motor and paste it, and now change the name. So it's going to be drive end bearing horizontal. Save. And then axial, same thing, copy structure only, go one step up, paste it in, and then just edit to drive end axial. Okay, so as you can see, we made a complete setting on the motor. This is one style. As I told you, you can do it differently if you have enough nodes. If you don't have so many branches before, so you can divide motor into drive end and non-drive end, and then within drive end and within non-drive end, you can create vertical, axial, horizontal. Of course, if you are not using vibration, it will simplify things a lot in the setting, because you don't need vertical, horizontal, and axial, because you will be doing ultrasound only in one direction, so you need only one point. We did it here simply to show you when you want to make all the settings, what are the things you need to pay attention to. So we did all that, fine. Now let's just think about it for the moment. How much information do we have here? We have information that we have non-drive end bearing and vertical. Fine, that's okay. But can we add a little bit more information? Because it will not change much in our work, but it will change a lot once we start organizing our work. So let's ask ourselves a question. Is this bearing sealed, or it's being greased? It's being lubricated. Is it lubricated with oil or grease? So if it needs to be lubricated, why not just putting a small L here? So it is lubricated. It's not a sealed bearing, so somebody needs to take care about it. And if it's lubricated with grease, why not just putting LG? So saying yes, it's lubricated, and yes, it's lubricated with grease. So I'm doing this because later on I can really easily filter out all my bearings which are lubricated with grease, as opposed to all my bearings which are sealed. So I can say, show me all the motors which do not have sealed bearings. They are lubricated with grease, and I can extract them out and take a look. There can be a million reasons for that, but one of the reasons can be, yes, we are doing great condition monitoring, but it seems that we have a lot of problems on grease lubricated bearings, so let's talk to the lube team. That's one of the options. So having it easily filtered, it's quite interesting and quite a good thing. So why not doing that? So we can put LG to all of them as an additional information because they are all lubricated with grease. So just give me a second, and I hope you are doing the same thing in your software right now, because that's the only good and successful way to learn something, by doing it. So let's move also here, LG, and the last one is going to be LG. Fine. Okay, now we took care of the motor. We have everything there, everything is fine. Now we have additional option if you really want to play, if you are a visual guy who wants to see that. So we can go just check utilities, system images. What do we have here? So we have some images, fine, that's okay. But we can upload some new images, and that's always useful. So let's see where we can find something interesting. Okay, pictures for icons. Okay, well, this is a nice one, the motor. Cool, now it's here. Let's upload more. Nice picture of the bearing. You can upload anything you want, just be careful, it's a small picture. Fine, we can put a pump there also, it will be useful. And a small icon of pump, nice. Good, now we can set it here. So now let's go to pump number 1 and edit this point a little bit to make it a little bit more beautiful. So I will add icon, and this is going to be my pump, the whole train. Good. Now it has an icon. Now my motor can also have a nice icon. He deserves that. Okay, select, save, it's here. And of course, non-drive end bearing, it's a bearing. So you can choose a nice icon if you want. I'm just showing you the opportunities. You don't have to do it. Do it as you like. Some people are more visual, and sometimes when you are showing to other people what you are doing, I notice that they like to see those icons, because then they can visualize what you actually do, especially when you are talking when we are trying to represent your results to people who are not really involved in condition monitoring but are making some decisions. So this can be quite helpful because people visualize much easier what you are doing. Okay, now we have it all. But of course, now we have a motor itself. Why don't we add some navigation picture to that motor? It can also be quite useful. Now let me find something. You should find something in your computer what you actually have. Well, it seems I don't have much here. Let's see, where do we have something? Okay, machines. Right. Okay, let's put this motor as a picture. Right, now I edited this point, the motor itself, with additional navigation picture. Where is it? Now if you click here and you select yes, show me navigation picture pane, that's your motor. So your motor is now here, and that motor has a lot of different positions. You can see these points here that you can now put on the right place. So this one is drive end bearing vertical. Good. That one is going to be here. Non-drive end bearing vertical. So that one is going to be here. Let's see further. So this is non-drive end bearing axial. Probably here. This is drive end bearing axial. Let's put it here. So this is drive end bearing horizontal. Let's put it here, and therefore you will find all the others and put them on the right places. So what you have here, if you click motor and then you click drive end bearing, it will lead you directly to this point. So you can use this navigation and actually navigate through the machines and its measurements exactly the way you want. Here it will take you directly to temperature, directly to vibration and other vibration measurement. So navigation picture, and if I go to parent here, navigation picture serves the purpose to help you to locate the measurement points much more easier. So if you like using it this way, here it's how it is used. Now we have another question that we need to address, and that doesn't have really anything to do with functionalities of UAS3, but do we really need the axial measurement on both drive end bearing or non-drive end bearing? Many of the colleagues told me many times actually not. So you can remove it if it doesn't need to be done, or you can just leave it here. So it's not a matter of functionality of UAS3. So now we have a motor, and we have a possibility here to expand all. When we click expand all, from the motor it will expand the entire branch down to the leaves, meaning it will open all the nodes down to the measurement level, so you can see them all here. Fine, we did a lot of effort here and we did a lot of work here, so I'm just wondering, why don't I first collapse it all? My pump also has 2 bearings. So why don't I just be the lazy guy and delete the pump, copy the motor, this time structure only. Remember, if you have data, it will copy also data if you use copy. So I will copy structure only, go 1 level up to the pump, and I will paste it. So yes, I have the motor, but it's not actually the motor, it's the pump. We are just being lazy and helping ourselves. The node icon, no, it's not that one. I will choose this one, but I will also remove this one. So now I have a proper icon. Navigation picture, we can remove it here, and we can see, do I have any nice pump picture here? Well, let's use this one. This is entire pump, but okay. So you can see I have everything here now. Now I have non-drive-in bearing, drive-in bearing, everything is here what I need to do. Because I prepared all the settings. So what I can do now is, first of all, we can be in a situation that pump is lubricated with oil. So we will make a first edit and we will say LO, because it's not lubricated with grease, it's lubricated with oil. So this is the first thing we need to do, and please do it in your software as well. This is time to practice and time to learn. Lubricated with oil, edit, lubricated, with oil. Same here, and same here. Good. Now we basically set up the pump as well, non-driving bearing, drive-in bearing. But there is also a different logic that we are going from non-drive-in bearing on the motor to drive-in bearing of the motor, but then we are going to drive-in bearing on the pump. So why not just changing the order? You change the order and you can move it up and down by drag and drop. So you can see I click it here, select it, hold my mouse, go up to this point, and it will be removed. So I have drive-in, 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 and all three non-drive-in. Of course, this is in case I'm using both ultrasound and vibration, so I want to have all three directions measured. Of course, don't forget that ultrasound is only in one of them, because you don't need all three. But pump is very interesting because on the pump we have additional thing, and that's volute, the body of the pump, the place where we measure the cavitation. So I will add one more point here, another measurement point, and that measurement point I will call volute of the pump. Save. And inside that volute of the pump, I will make a new measurement setting, and that measurement setting will use RS2T. Let's do it in high resolution as well, in the focus mode. And I will use the same interval because it's the only logical way to use the same interval. But considering that I want to hear what's going on with that pump from the perspective of cavitation, which is a random event, it's natural event, so I will lift it up to 10 seconds. Maybe too much, but it wouldn't hurt. 10 seconds, wasting 10 seconds, it's not a big deal, but it will help a lot. And I will save it. So now I also have the volute. And more or less I have everything. I just set nicely my pump 1 with a motor and a pump. All my measurements are inside. So again, as a lazy guy, if you want to do the job easily, hire a lazy guy, because he will always find a way to do it in a simple mode. So I will copy structure only of pump 1. I will go one level up to pump 2, to pump group, and I will paste it. And that's going to be my pump 2. With all its elements inside. As you see, motor and a pump, everything is fine. But I will add one more explanation, simply because that might be the case. I will say that pump 2 is actually backup. So it will help me later when I want to filter the data out. If I want to say, okay, it's a third Saturday in a month, now we are starting the backup pumps for a few hours to work. So now it's a good day. Please filter out all the backup pumps, put them in one work order, and go out there and do the job. So putting these nice names will really help you a lot. So we created pump group number 1 with 2 pumps, pump 1 and pump 2 backup. But we probably have several groups with several pumps and backups within them. So let's copy structure only, go one level up and paste it. And now I have pump group 1 copy. Of course I will edit this and I will call it pump group 2. Nice. Now I have pump 1, pump 2 backup. Probably I will call this pump 3. And it's going to be here pump 4 backup. Nice. Of course, the names you are putting here, just for the purpose of practicing, I'm putting pump 1, pump 2, 3, 4. This is going to be names you use in your organization. So those names needs to be clear to everyone. Pump group number 1 or 2 can be east and west, north and south, close one, far one, blue one, green one, whatever you want to name it. But those names needs to be something that everyone understands, especially the person who's going to collect the data, because the same name of the asset will be displayed in his software, in his firmware on the instrument, excuse me. So that means he needs to clearly understand that. And if there is a name of the pump which called PW71, then put PW71. That's the name it should be. Now for the training purposes, we are just putting 1, 2, 3, 4 or whatever else. But these additional things, backup or this, it's good to be in the name, because then it will help you filter data as I told you. But actually I have 3 groups. So let's put group number 3 as well. So that's going to be pump group number 3. Save it. Open it up, and this is going to be pump number 5 and pump number 6 backup. Okay, pump number 6 backup. Now we have a certain amount of assets. We did some nice job, you did some excellent job, and we made some good mistakes. Mistakes are good, because we will not copy paste a zillion times and then realize we made a problem. So make all your mistakes in first several assets, please. And from this point on, after 2 or 3 assets, or 6 in this case, don't go too far. Now let's do some work and then see if we actually did it really good. If it's not good, there will be still very fast and very easy adjustments, and then we can move on. So for the moment, let's put this in, let's create a work order. This is another chapter which we will discuss now. So I have many ways to put something in a work order. First, some facts that you need to know. You can see on the screen, and this is from the manual, so sometimes you really need to read the manual, sorry. Work order or survey is an organized task. It's extracted out of the tree structure. So what you need to remember is this, that one item can be in several work orders or surveys. So you can take one item and put it in a work order with name Monday, with name of the operator, with name of the monthly, or whatever you want. You can put it in different work orders. So work orders, they do not affect tree structures at all. So the tree structure is how you set your assets when you want to look at them, analyze the data, understand what's going on. This is what you are doing as a person who, condition monitoring engineer, in front of the computer. But when you're in the field, it may not necessarily be the most efficient order. So you can change it, you can do whatever you want, it will not affect the tree structure. So the work order survey is actually a list of selected items, tasks, put in one list where you will go out and do it. So you can play with it as much as you want. Now you will probably remember what I said at the beginning. Do not necessarily build your tree structure in a way you will go out and collect data. Do it in a way, the most appropriate way to look at the data. And about collecting the data, we will do it in the work order survey. We will adjust that and optimize this work order to be the best possible way for a technician to go out and collect data. The most logical way, safe way, or whatever you want. So you can create as many work orders as you want. There are really no limitations. You can do whatever you want. Sometimes people just delete work orders and create new ones. If you ask me, not necessarily, because most of the things will be repeating. So something you do on the first Monday in a month will happen next month as well. So there's no need to delete them, but nothing stops you to do that, and you can rebuild it again. Work orders can contain items from one tree structure only. So what I have in this tree structure, I can put in this work order. I cannot have two machines in two different tree structures and then put them in one work order. It doesn't work that way. What happens in the relationship between software and instrument is a master-slave relationship. So the master, the software, puts the database, this particular tree structure with all the information within, alarms, work orders, settings, everything, put in the instrument, and then instrument actually works based on that tree structure. You cannot put two tree structures. So when you are setting it, you need to put the logical set of assets in one tree structure. But you can create as many work orders as you want. You can combine them any way you want. You can put them in different order, and this is what we will do right now. So let's put it this way. So I will create a work order which needs to be logical for me or my technician to go out and do the job. From the point of the person who is looking at the screen, this is quite okay, because I see pump group 1, pump group 2, pump group 3. I see pump and a backup pump. So if I'm thinking about a condition of my pump 1 and I see certain problem and I want to plan some activity to change bearings, to align the pump, to balance the impeller, whatever, it's quite useful to have at the same point pump 2 backup. And then I will check the condition of pump 2, which is backup, and I will say to myself, okay, pump 2 is in a good condition, so I can easily plan repair of pump 1. So it's quite interesting to have them at one point together. But it's not really logical when you go out in the field, because they never work together. So setting the work order where pump 1 and pump 2, which is backup, are together doesn't make much sense, because you immediately know that the job will not be done. So it will just unnecessarily confuse the technician, it will confuse you, it will confuse anyone. There might be someone saying, yeah, I must do it, let's start the pump, let's change everything. Unnecessary complication. Follow your logic. The UAS3 is here to give you the opportunity to do the job the way you want it to be done. So let's do it this way. Let's say that pump groups 1, 2, and 3 are in the same building, so they are quite close. So it's very logical to do it all at one shot. So go out there, take the measurement, and come back. Fine. But at that moment, the backups will not be working. So let's do it separately. So let's do this. I will select pump 1, right click, add to work order survey for the instrument 340. I can only add it to new because I still don't have any work orders in my selection. I will click it here and I will call it, let's say, pumps inspection, and save it. The list is here, the work order is here. So you can see pump inspection contains, I'll just open this up a little bit so you can nicely see it. Sorry. Okay. So it contains the root of the database, training, water recirculation, pump group 1, pump 1, motor, non-drive end bearing vertical, lubricated with grease, temperature, acceleration 10 to 1, acceleration 10 to 10, everything is here, everything from pump 1. Good, so that's pump 1. But we know that in the same time we will be collecting data from pump 3 as well. So let's select pump 3, add to work order survey, and now it's offering you wanted to add it to new one or you wanted to add it to existing one. Of course to existing one, because I will have all my active pumps there. I will do the same thing with pump 5. Right click and add to pumps inspection. Good. So let's see what we have here now. My pump inspection is now a serious work. It's a nice, cool, serious work. So everything is here. Excellent. Now, what about backups? Now I can create a new work order which will contain only backups. And I will call it new work order survey. I will call it backups only. And I will save it. Now my pump 2 is backup is here already. I will add others to backups, and I will add also this one to backups. So now you can see I have my regular pump inspection. I have backups only as a separate job because that will be done in some other time, the way we plan it. So this is how I add something to work order. But I can also do it in some different ways. So I can click here on my water recirculation. And I will go to bottom pane, open it up a little bit so I can see better. I will click on selection and I will click on filter. Okay. Now, the way to select something out works in this way. Let's say I want to check only grease lubricated bearings. I put LG. So as you can see, only LG is here now. So it's filtered out. Okay? Considering that backups are not working constantly, so I can play that game a little bit more. And I can say, yes, but I also want it to contain word backup. Nice. Now we have two filter criteria. So now what is selected now, what is extracted now, is all the backup pumps with grease lubricated points, which is excellent. Now I can do it as a separate work. So nothing stops me to select them all. Go down, press shift. Now they're all selected. And now tell me, what do you want to do with them? Well, I want to create another work order. And that's going to be a new one. So I click on the work orders in the bottom toolbar. And I said add to new. And what we will call it? We will call it grease lubricated backups. Why not? Because they don't work very often. We cooperate nicely with lubrication teams, so we want to check them extra because there might be some problem if it's really cold and the grease is very dense. There could be million reasons for that. But what I want to show you here is how to extract certain points out. And we can say, okay, put it there. Right, now I will remove my filter. And let's hypothetically put another situation here. I have a technician, a process technician, who is sometimes checking valves and all the other stuff. And I can easily ask him, can you please just check the body of the pump, the volume for cavitation, while you are playing with the valves? Why not? Probably he will say, nah, don't push me into the bearings, that's not my job. But of course, easily I can put the sensor and listen to cavitation and collect data. That's a great job, because I will be playing with valves anyway. So why not? I can put here the keyword volute. So you can see I have 1, 2, 3, 4, 5, 6. I have 6 volutes on my 6 pumps. And that's great, but I want to send him to pumps that are actually working right now. So I will use control button and I will skip the backups. So I will take only these 3 pumps and I will add it to new work order, which will be called, let's say, cavitation check. Good. I'm doing more work orders simply to show you what else you can do. But if you click here, you see I have a lot of work orders. So what you are creating here is an excellent menu. It doesn't touch your tree structure at all. It doesn't affect your work as a condition monitoring behind the screen at all. So if you go here, everything is still the same. It's perfect. Now, how the data will be collected, how you will optimize that work, who's going to do that? Sometimes it's going to be a grease guy. Very often it's going to be a condition monitoring technician. Sometimes it can be actually an operator, somebody from the process. So if the operator is there to play with valves, why not checking for cavitation? If the grease guy is there and doing his regular grease job, why not? He can do this. So this is created with optimization in mind. So you have a full freedom to do whatever you want, and that's the whole point, without touching your tree structure. So if you go back, your tree structure is here, nothing is changed, everything is nice and perfect. So we will kill the filter now. We don't need it anymore. Selection, everything is here. So our next move to do is just to go through this and see if we did the job right. So yes, we have pump 1 motor, non-drive end bearing, vertical, horizontal, axial, because we are taking also vibration. Then we go to drive end bearing, nice, we have everything we need. So there is a volute position also on the pump, the same thing with the backup. Excellent, excellent, it's good. Now let's go to the work orders. And let's take the simple one, the shortest one, just to be able to show you. And we say that he will be checking a cavitation, for instance, on the volute. So this is my position. Pump 1, pump 2, pump 3. This is the order how it will be shown. But we can say, no, let's put the pump 3 first. Let's put the pump 3 first. Let's put it in reverse order. So now we have 3, 2, 1. So nothing stops you to change the order. If you remember what I told you in the beginning, don't bother with the tree structure. You can change everything in the work order to optimize the work for your condition monitor technician, to make it simple, nice and safe for him. You can do the same thing in all of them here. Just change the order. So nothing stops you to do that. As a matter of fact, you can, let's delete one that we can easily find later. So the last one, you can actually delete that one. So I deleted 1 point for whatever reason. So what I'm trying to show you here, that you can change orders, you can delete certain points from the work order, and you can add a lot of other points to work order. Now what you need to pay attention to is that 1 point cannot be in the same work order twice, because it's simply not logical, but it can be in multiple work orders. And when adding something to work orders, you can add an entire branch, node. You can actually add a certain leaf, as we call it, leaf, the measurement point. You can add also this. So you can choose whatever you want. It's absolutely flexible. There are no, I will not say there are not rules, but there are no restrictions or limitations for you to build exact work order that reflects the reality in your organization and in your work. So what we will do next is this. Let me show you. So you see my instrument now. Okay, so I turned on my instrument. I connected my instrument with USB cable to my computer. I go back here and I say, okay, device 340, upload from PC to 340. Because later you'll be downloading from 340 to PC. So upload from PC to 340. It's telling you now SDT device is ready. If it's not ready, refresh it. If it's still not there, change the USB port and make sure your instrument is on and connected to your computer. Okay, now we will transfer the data. Before transferring the data, UAS3 will warn you that transfer of the new data will delete everything old, what is already in the instrument. So just to expand on this a little bit, when you come back from your work order, from your task, from the field collecting the data, and you download all that data from the instrument into the software, it's still in the instrument, it's not deleted. Just in case. There's no reason to delete something, memory is cheap. So we are not deleting it, because whatever happens, at least you have your last set of data in your instrument. So it will be deleted when you upload the new set of data to instrument. It will delete the old one. So UAS3 will just warn you to make sure that you deleted, for instance, yesterday's task, because now you're uploading new task. So I will say, yeah, okay, I did it properly. So it will check the device, and it's now transferring all the data that we have. We still didn't build any alarms. We will do it in the next chapter. We will play with that a little bit. So as you can see now, upload was completed successfully. 0 alarms, 0 events, 1 operator, 4 different surveys, 4 work orders, 198 measurement nodes, and 0 measurements because we don't have any. Okay, that's it. So now when we transfer the data, it's time for us to go to work. So what do we have in our instrument now? We have the tree structure with all the settings down to the leaf level, what needs to be done, what is acquisition time, what is emissivity, what is the sampling rate. Everything you set in your software is now in the instrument. All the alarms are in the instrument. We didn't build any yet, but we will, surely. But that's transferred also. All the work orders are transferred as well. So everything is there. Now, practically, this little job we just did is now in the instrument as well. The good thing is that instrument will every time take another job that you give him without any changes. So I will explain how to build alarms, because that's going to be our next job to do. So what we did until now is that we built these 3 pump groups. We created some nice work orders. We created them on a different criteria. We learned how to filter the data. We learned how to move the data up and down to adjust our work order to be fully optimized for the technician in the field. We realized that it doesn't touch our tree structure at all. So we added some nice icons. We added all that needs to be done. Every measurement has a settings. As you can see, settings are here. You can edit settings just by clicking right button on your mouse and saying edit. You can change it here, but don't forget to transfer it again to your instrument, because then changes will be effective. So we prepared a complete job, and we can go out in the field and actually do it. But let's also put some alarms. Let's learn how to work with alarms a little bit. So when we speak about alarms, we can speak about primarily 2 kinds of alarms. The first is a template alarm. You can find them here. Utilities, alarm functions. So alarm list is like your alarm bank. So you create certain alarms monitoring certain sensor and a certain indicator at a certain value, and put it here in a bank. So it's like your template. Then you can attach that alarm to any points or multiple points that you want in your tree structure. But you can also use a node alarm. This is an alarm that you set up directly in the node, and it doesn't affect any other node. The reason to do that is, you will learn quite soon, is that when you want to add something to multiple points, alarm. Let's imagine you have a conveyor with 80 bearings, and they are more or less all of them are somewhere in the same area with what we consider normal. So you will try to put alarms on all of them, equal alarm. Fine. Then you will basically create an alarm called conveyor bearings and attach them to all of the bearings on that conveyor, if that's reality of the condition in the field. But one day you have one bearing behaving strangely, and you want to change the alarm. If you change that template, the change will affect all of the bearings where it's attached, and maybe you don't want that. So for that purpose, and for purpose of customizing for each point, you will be using node alarms. So let's start with alarm list. Let's create an alarm that will be able to attach later to all of the points. So Here you need to first click New. You will create new alarm. When you create new alarm, the first question is what sensor is it attached on? So what sensor is considered? So I will say, in my case, let's put it RS2T. Okay, but which one? Be more specific. Yes, 256. So RS2T, focus mode, 256 kilosamples per second. Because there can be some other settings where sampling rate is lower, 32 kilosamples per second. But we mostly put everything 256, so let's stay with 256. What will be the alarm name? Well, for the purpose of understanding easily, let's differentiate it quite easily. I will say cavitation alarm. Now I will be inventing some numbers here, of course, because we still don't have any data to base that alarms on. So I'll just improvise because the purpose of this tutorial is to show you how to do it. So the next question is, just imagine that you are communicating with this alarm and he's asking you, okay, what do you want me to monitor? I can say, well, you can monitor RMS, you can monitor max RMS peak and crest factor for the RS2T, for the ultrasound sensor. So I will call this alarm cavitation peak. I'm giving it this name so I can easily find it later. And I want him to monitor my peak value. And I'll say, yeah, I want absolute mode on, and based on my already collected previous data, please be so kind and when the peak is more than 50, show alert. When it's more than 56, show me warning. When it's more than 62, call it a danger. Okay, so now we have the absolute mode on, and now the alarm will be monitoring on that sensor with that sampling rate, on that indicator will be monitoring this value. But I can also put the safe mode. So I can say, yeah, safe mode on, so the lower limit, if the peak is 10, then I want to be alerted because that measurement is not correct, absolutely. So A, the sensor is on a completely wrong position, B, machine is not working at all. So it's a good thing because then you can filter the bad data out. And of course, if my peak is over 100, if my peak is over 100, also please warn me about that. And then we can say a relative mode. The relative mode, if you click the relative mode, you can monitor if the value is increasing or decreasing in respect to A, previous value, first value, or reference value that you set. So let me just expand it a little bit on this. So relative mode increasing, warning when increased that much, and danger when increased that much. The same thing with decreasing. Please give me warning or danger if it's decreasing at a certain level in comparison with the previous value, or first value or reference value. Now, if we use the previous value, I will ask you to be very cautious, because if you say if it's increasing 6, then give me the relative alarm. Give me the alarm that something is actually changing. It's still within the absolute values, but it's changing. It can be problematic if you are not completely aware of the structure of your data and the intervals, because it can be increasing if you are measuring it very, very, very densely. So let's say, just to go to the extreme, every single day, and every day it increases by 1. So after 6 days it will be increased by 6, but this alarm will not trigger because it's comparing with a previous value, and previous value was just 1 dB microvolt down. So just be careful about that and pay attention. You can do it based on the first value. So you can say to your alarm, please compare this new measurement relative to the first value we ever measured, or to the reference value, which is also a very, very intelligent thing to do, because first value is not necessarily a good one. So for 2 reasons. You are not starting your condition monitoring in a brand new organization. Normally it doesn't work that way. The second issue is that the fact that the machine is brand new and installed right now does not necessarily mean it's good. So you don't want just by default to say the first measurement is the best measurement. It's not necessarily the truth. So you can also choose the reference value, and here you will select which one. Still, we don't have any, so we cannot use this. But I just wanted to show you how you will do that. So you will choose one of those, and saying, okay, if it goes up by 3, give me warning. If it goes up by 6, give me danger. Decreasing is normally used on crest factor, because when crest factor decreases in a progressing defect, it's quite a bad sign. That means that your RMS is going up and a peak is staying the same or going up, so crest factor will be decreasing. So it's very useful as well. For the moment, I will remove it because we still don't have any data, so it cannot be relative to anything. So I will remove it. And by this, I configured my alarm with the name cavitation peak, and it has a value, absolute mode and safe mode. Later on, down the road, I will use also relative mode, and I will save it. So you can see in my alarm bank, right now I have one single alarm. Okay, that's a good beginning still. I can put another one. I can put this one on vibration, on accelerometer. 64 kilo samples per second. Let's say 10 hertz to 1 kilohertz. Alarm name will be, I don't know, WIB1. Just keep the name that will associate you. I'm just using number 1 just like that. It will associate you what is this alarm for. Or you can say it, let's put it this way. Motor non-drive end. And I want you to monitor peak acceleration. And then I can say, okay, absolute mode on. If it's 2, if it's 3, or if it's 4. Absolute mode, alert, warning, and danger. I can also put the safe mode. I can say really if my peak acceleration is 0.5, that might be that machine is not working at all, or my upper limit if it's let's say 25. That's probably the wrong measurement. You can also use the relative mode as well. Now we don't have any data, so I will not use it, but put it in the bank. Of course, this one will be monitoring peak acceleration. So I gave him the name VIB motor non-drive end. It's considering accelerometer, 10 hertz to 1 kilohertz, and it's monitoring peak acceleration. If I do the same thing with the same parameters, 10 hertz to 1 kilohertz, I give him VIB motor non-drive end, and I said I wanted to monitor RMS acceleration, and I will just now put any numbers, really any numbers, and I will say save. Alarm name not entered. I will call it RMS. Fine. So now I have this one monitoring RMS acceleration, this one monitoring peak acceleration, and I can attach them, because those are 2 different alarms, I can attach them to the same point. So if you count a little bit, you can see here that I can monitor 4 different indicators on each point, and each indicator will be monitoring 3 absolute values, 2 safe values, and 4 relative values. Multiply that by 4 indicators, and you will see that it's big number of eyes monitoring each point. You just have to set them properly. I'm talking about numbers. So look at the data, understand what is good and what is bad, see how consistent your data is. The more consistent the data is, the more sensitive alarm you can put. And this is the way you put alarms. Yes, I want to exit. So I have certain alarms in my alarm bank. So let's close it now. Fine. What I can do now is I can go to my pump, volute, and I can add set alarm from template on this measurement, RS2T focus 256. And you remember we choose the alarm which is for volute, because we are probably looking for cavitation. So we have only 6 points here, so I just wanted to make it simple for you. I can say set alarm from template. So what you can see here, considering that I was clicking on RS2T focus 256, my alarm system is immediately offering me only alarms that I have set on this sensor and this sampling grade. If I go here and if I go here, I have no more to choose. I have just one. If there are more different alarms that are considering this sensor and this sampling grade, I will be able to choose more. So I will just be going through and browsing through all the alarms here, left and right, choose the right one. Now I have just one, and I will say, okay, attach it. So now it's attached to this point. How can I see that? So click on this point. Here you are in tab readings. Obviously we have no readings. We know that also because there is this folder icon. But if I click on alarms, here it is. So now I know that there is an alarm set on this point and on two criteria. It's the name of the alarm is cavitation peak, alert 50, warning 56, danger 62. But there is also a safe range between 10 and 100. So if it's lower than 10 and if it's higher than 100, it will trigger the alarm. So the safe range is, let's say, defined between 10 and 100. Of course, when you have some data, you will define some reasonable safe range. So this is how you will see this alarm. You can go point by point and add alarms. But if I have 6 pumps here, and more or less, if, of course, big if, they are operating in the same range, they are in a similar condition, with a certain tolerance, of course, because don't forget the baseline or the good line is never a line, it's an area. So don't expect your 6 machines to work in absolutely identical way and give you identical numbers. That will not happen. You will not have identical values of readings after 1 month, after 2 months. They will always fluctuate a little bit. So that's how I will create alarm based on the real data. So for the moment I will remove this alarm. So I showed you how you can set alarms point by point, like a pedestrian, slowly. So I will detach this alarm. And if I click here, you see, alarm is gone. It's not gone from the template. Alarm functions, my cavitation is here. So my setting from this alarm is still in the bank. I will use it when I need it. The fact that I detached it doesn't remove it from the bank. It's still there. But I also want to show you how to add them as a group. So I can click on my water recirculation. I can make a selection, filter, and I can tell him here, I will write it again because I want you to write it again as well. So volute, as you can see, I have 6 pumps, 3 leads and 3 backups, and I have 6 volutes, of course, and I would like to monitor those volutes on a regular basis and have alarm on them. So I will select first one, shift, last one, select them all, and I will say alarms. Now, in alarms menu, in a bottom toolbar, it says show me the points in alarm. Attach with existing, so that means show me existing alarms and I will attach one of them because I already have one in the bank for me. Attach with new, so that means I don't have alarm for this point, but I will create it right now. Or you want to detach all alarms if you have them already. In our case, I will attach with existing. So attach with existing, and it's telling me, yes, you have this one available for this sensor, and I will just click attach. So with this, what we did right now, if you click on any volute, you will see please do the same that I do, and you click on alarms, the alarm is attached on all of them. So it makes it quite easy when you have group of assets that behave more or less in the same range, and you create one alarm and you put on all of them. Now let me also show you that you can go this way. So I will click water recirculation, so show me everything. By the way, this number here shows you how many leaves at the end of the tree, how many measurement settings you have in this selected area. So in this area, water recirculation, I have 198 of them. In pump 1, I have 33. So I want to see them all. I will again click selection, filter. I will choose my volute. I will select all of them. Click on alarms, and I will say attach with new. So I have a great idea for alarm. I now also want to monitor crest factor on these pumps, because I have some data and I have some ideas. So as you can see, these two things are automatically defined. It's RS2T focus 256 kilosamples per second, because they're all that. You cannot put focus or 32 kilosamples on this one. So I can call it cavitation crest factor, and I want you to monitor crest factor, absolute value of crest factor. If it's more than 7, give me alert. If it's more than 10, give me warning. If it's more than 13, show me danger. Now, of course, the safe mode, I can also say, if crest factor is less than 3, that's not going to be realistic, honestly, because if crest factor is less than 3, I have a reason to suspect that the signal is clipped. So it's a good idea to have this alarm on crest factor, because if you have crest factor 2, there is a high probability that the signal is clipped. And the upper limit, I can just invent it now and say 60. Everything in between is, let's say, okay measurement. Everything is healthy. You can also use relative mode, as I explained it before. So in this process, we choose the assets, you choose the measurement points and settings, and we say, yes, I want to attach a group alarm on all of them, but I want to create a new one. So this is exactly what we did. We created a new one, we will save it, and it's attached. So let's check one of the volutes. And you see we have 2 alarms attached on volute. The first one is cavitation crest factor, as we say, 7, 10, 13, and the safe range is between 3 and 60, and the cavitation peak with the same numbers we had before. So the group alarm is now attached, and we are all nice and happy. So let's put some alarm on a vibration. So because there is a possibility to make a small mistake, and I just want to help you with that. So you can see acceleration 10 Hertz to 1 kilohertz 64. So let's see what we have in the bank. So set alarm from template. Yes, we have one for that. So we can assign it with no problem. I will assign alarm, and here it is. So that's my alarm. I can assign much more alarms in the same way you just assigned this one, but not 2 alarms on the same indicator. So you cannot have 2 alarms monitoring peak on the same machine, because those are then conflicting data. You can have one monitoring peak, another one monitoring crest factor, RMS velocity, RMS acceleration. Of course, if I click here and want to add alarm, set alarm from template, I don't have any. See, there are no alarms defined for the selected measurement, because this measurement is 10 Hertz to 10 kilohertz. And if you remember, I go to my alarms, there's nothing I set for the range 10 Hertz to 10 kilohertz. So your alarm bank is saying, sorry, I don't have one. I would like to offer it to you, but you don't have one. So you should go there and set it and create that alarms. So this is how you work with a template alarms. You can attach them individually. You can attach them as a group when you select from the bottom pane and you add them as a group. You can detach them individually or as a group. So again, the same way I attached it, I will select items and detach it completely. But there is another way to work with alarms, and it's very important for you to know it. So let's go back to Volute, because on Volute we already have two alarms. So we have two template alarms. One is monitoring crest factor, another one is monitoring peak. Now for this particular pump, and this is the situation when I will use my node alarm. For this particular pump, I realized, and I already have sufficient data to come to that conclusion, I will set node alarm. So this is individual alarm. It's not in your alarm bank. It concerns only this point. So I will say, I want you to monitor RMS for me, and absolute mode will be, let's say, 25, 31, and 37. I have certain data consistency, I came to certain conclusions, and I can say that this pump is beautifully working at 19 or 20 dB microvolt, whatever. I'm just inventing number here. And I want my alarm to be from 25, 31, 37, because I have sufficient data. For other pumps, they are not really so stable, they are going up and down, and so there can be many reasons why you want to put this alarm individually. And then it will be, you can attach it to node. And if you take a look, I have another one, but this one is marked with a small bell. So that one is node alarm. It's not in your list. These two, they are. So this one is local alarm, and this one is picked from your alarm bank. And it's very important because probably you will be playing with alarms a lot. So do it properly, because they will help you greatly to do your job nicely. Now, you can also detach that alarm, of course. As you can see here, detach alarm individually. Here in this menu, right click on a measurement point, you can detach all alarms. But if you only want to detach one alarm, you can detach that alarm individually. So use that option. You don't want to remove all alarms if just one of them is problematic. So I have this node alarm, and I can go here and I can again do set node alarm. He's opening me the one I have already, and there is a mark here, alarm is attached. So yes, I have it here, I attached it already. I can choose another one. But what happens if I have situation that all my other pumps, now I have enough data, consistent data, they are stabilized. And this alarm that I actually chose on pump number one is now it's the alarm for all the pumps. And I want to use it on all of them. Now you don't need to copy paste, you don't need to do it again individually on all pumps. What you can do is copy it to alarm list. Now it's opening your alarm bank and saying, okay, you want to use this, you want to copy this alarm into the template list. Yes, I want to do it because I want to do it on multiple points. Nice. So first of all, it's blinking. Give it a name. So I can say, I can call it Volute RMS. Okay, you gave it a name, save it. And now you can see this alarm is also in bank. I'm trying to explain you this in this way because at the beginning of your condition monitoring program and using UAS3, you don't have enough data and enough consistent data, and you are not working with assets still enough to have all the assets certainly stabilized to a certain level and having more or less consistent data, and you cannot understand the asset based on one measurement. So at the beginning you will probably start with node alarms individually. So you look at the asset individually, but then after certain activities, interventions, maybe some alignment, balancing, changing some bearings, whatever you will do, you can say, okay, now my free pumps are quite stabilized and they are more or less in the same range, never equal, but in the same range. So let's put some template alarm. In that case, you can choose alarm from the node alarm, save it as a template, and use it for all of them. So what I will do right now is I will close this, and you can see that on this pump I have it as a node alarm. I cannot attach another one on the same indicator. So I will try just to show you why it doesn't work. So I will say set alarm from template, and here I have cavitation peak, cavitation crest factor, volute RMS. So you can see now I have more alarms, so I can browse through alarms and choose one. So this one is monitoring RMS, and I will say attach. As you see, it's telling me, sorry, you already have alarm watching the RMS, so you cannot use another one. It doesn't matter if it's same, but it's just conflicting. So it's saying, no, you cannot do this one. Okay, I will not do that. I will remove this one. I will remove node alarm. So you can see it's gone. I will now choose all my volutes. So water recirculation, selection, filter, readings. I will put the keyword volute, select them all with clicking first, shift, clicking last, alarm, attach with existing. Which one you want? Peak we already have, crest factor we already have. Wow, that's the new one. Attach. I already put it somewhere. Sorry, I have to remove it. See? So I have to remove it. Crest factor peak. Now we have to remember where did I put it. So I obviously put it somewhere. Okay, I will have to check that later, but anyway, we will not be adding it now because we don't have any data anyway. So now we add some alarms, and not on all of the points because we don't have any data. So the alarms we put now, it's just releasing some balloons. I'm just inventing the numbers, so don't do that. The point is to show you how to set alarms, not what values are good or bad. Your data will tell you what value is good or bad, and that's what counts. Also, I want to show you how you will set the events. Events are quite important in condition monitoring because it's an information. It's sometimes critical information to understand the behavior of the asset. So we can say on this motor, we can add new event. So we can say on 19th of April 2021, we can say that motor repaired, bearings replaced. Save. So right now when I click on the motor, I click on the events, here it is. I know that day we did something with this motor. At the very beginning it doesn't make much sense, I understand. But you can just imagine that if you have a certain trend, certain amount of data monitoring this point, and then one day the numbers are completely different. And you have no idea why, because nobody told you that while you were at the vacation, we replaced the bearing of that motor, we aligned everything, we balanced the fan, and now it's a completely different situation. And of course your numbers are completely different, and your alarms are not really accurate anymore. They don't work anymore for this new condition. So it's really important to document everything. The condition monitoring is not only the data that you see in the graph, it's everything around it, and we are trying to help you to put as much as possible inside UAS3. So this is quite important because later on, when we have some interesting data here, there will be a point in your static trend saying, oops, on this day the motor was repaired and the bearings were replaced. and that point in your graph will actually clearly explain you that there is a reason why your signal changed. And of course, if you are monitoring this repair, it's a great place to say, okay, I can confirm that on this day with this message on the screen, after that the signal is beautiful, clear and nice, and the repair was successful and good. So put all these comments, put all these events, because they will be quite useful in understanding the asset behavior. Also, as I told you before, what you want to see in your graph. Now we come to the point that you want to see all the measurement since this event. So you can say, okay, don't delete anything, but just don't show me every time what happened before we replaced bearings. Show me just after that. So it's again a certain point in time that you can refer to. So as much as you can, put this data in, because events will really help you a lot. So there will be a collection of events here explaining what happened, why and when. It's like a nice reminder, a nice collection of data. So now we built our tree structure, we built our work orders, we set certain alarms. As you can see, some of our points have alarms, some don't, of course. And there is another thing I want to show you, because later on we will be playing with it a lot once we have the data. But for the moment, it's important for you to see that when you click the work orders survey tab, so here are your work orders, you will have a work order survey tab in your top toolbar. Click on it, go down, and there is a to-do list. So to-do list is exactly as the word say, to-do list. So this is your task planner. So you can choose what do I need to do current week, next week, current month, next month. Show me only my missed measurements and show me never measured points. Just want to expand it a little bit on this and explain you. So at the moment you take the first measurement, the clock starts ticking. So if you set the interval on 30 days, software will not tell you you have to go to measure it after 30 days, because you haven't started yet. The clock is still not ticking. With the first measurement, it will start ticking. So if you can, as you can see now, if I click, what do I need to do next month? Nothing. Well, that's actually good news, but it's not realistic. Why nothing? Because you still haven't got any measurement. And the interval 30 days cannot be calculated based on anything. So once you have the first measurement, then you will be reminded that in 30 days you have to do this and that. This is a very good way to plan your work, because you can come on Monday at your desk and you can say, okay, what do I need to do this week? And then it will take everything which falls in this week to be done. And in that case, some of our users, me very often, I don't use the same typical work orders that reoccur, because I don't know what will be the next month. Maybe one of the guys will be at the vacation, another one will be sick, so we will have to reorganize a little bit. What I do is I come on Monday at work, I click, okay, what do I need to do this week? And then there will be the whole list of things that need to be done this week. And then I can say, okay, this guy is at a vacation, this guy is sick, I have two guys, okay, let's reorganize it a little bit. And then I can reorganize it from here. So here I will select and add to new work order. The same goes with your missed measurements. Right now we don't have any missed measurements because we are not late with anything. We are in time. There is still no first measurement when the clock starts ticking. But this is a very useful feature to organize your work, because sometimes you will be late with measurements. If you are late 1 or 2 or 3 days, nothing catastrophic will happen. But if you start forgetting, that's not a good idea really. But what you can do when you come to work in the morning, you can select missed measurements. And here it will be certain number of measurements that are overdue. So the 30 days, the interval that you set, or 45 days or 6 months, doesn't matter, is overdue. So you need to do it. So by logic of the work, what is your first task? Your first task is to do the things that you are late with. So you can select them here and add them to new work order, which will be called probably urgent. So I will select all the missed measurements and I will put them in the new work order. The name will be do it urgently. And then somebody, or me, or you, or somebody else will go and do that urgently. You have also another thing which is called never measured points. So the software will extract everything you have in your work orders which has no measurement at all. So in later stages of your condition monitoring program, that will be, for instance, newly installed machines. So it will just remind you, okay, we have some time now, we don't have any urgent job today, let's do the new machines and take the initial measurement. So you can click here, never measured points. In our case, it's going to be quite a long list. You can see, because we have no measurements in our tree structure now at all, so the to-do list is telling you, well, my friend, you have a lot of never measured points. So I can choose some of them. I can say I will do this, this, this. I'm pressing Control button. So Control and select. Okay, I will do this and this and this. Right click, 340, add it to new survey, and I can call it urgent. This is exactly what I would be doing. This is exactly what I will be doing with my missed measurement. And here it is, urgent. So obviously I need to do this today. This is a very efficient way to organize your work, to be sure you will not be forgetting things, because it's normal to skip sometimes. It happens. People are not always available, but then you can remind yourself to do it. So we organized our work orders, we filtered the data from the bottom pane, we used certain tools from the bottom pane, we built our tree structures for 6 assets. We did some interesting job. We set up some alarms, and now we will transfer it to device with all new data, because we add some alarms, we add some new work orders. So let's transfer it now, and in the next chapter we will collect some data and then get back and see what we can do with data. How do we analyze the data, how we follow the trend, what do we do with alarms, and it's going to be quite interesting. So it's transferred to my instrument, and the next thing is to go and collect some data. See you in the next chapter. Take care.